All right, so in this video, we're going to be taking equations that are not originally in slope-intercept form, meaning equations that are not in y equals mx plus b form, and we're going to algebraically manipulate them so that we can get them into y equals mx plus b form. Why would we want to get an equation into slope-intercept form? Because once it's in slope-intercept form, we can then graph it. Why is graphing important in Chapter 5? So in Chapter 5, we're finding simultaneous solutions to a system of equations. And one of the methods that we started out with is graphing a system where we can graph two lines and then see where they intersect, and that point of intersection is the common solution. So on your test for Chapter 5, you're going to have to graph two lines and then see where they intersect. But those two equations may not be in original y equals mx plus b form, so you'll have to get them into that form. Okay, so here is an example where we have an equation that is not in y equals mx plus b form. It almost is, but not quite. So what we're going to do is multiply both sides by -1/2. If we multiply both sides by -1/2, then our y becomes isolated. So here we go, multiplying both sides by -1/2. Now, -1/2 times -2 turns out to be a +1. So 1y is just y, so we've successfully isolated y. Now we need to distribute this -1/2 over every other term in the equation. So -1/2 times a +1/2 is a -1/4. So that'll make -1/4 x plus 6 times -1/2. Half of 6 is 3, and it's -6. Or it'll be 6 times -1/2, so that's -3. So we'll add a plus -3. So then you could just finish out the equation by saying it's -1/4 x minus 3. This is an equation that you can graph because now you know that the y-intercept is at -3 and the slope is -4. Let's try another one. So in this example, we have both x and y on the same side. So what I suggest doing is, before you do anything, this is what I suggest you do. You get rid of the fractions. So before you do anything, I would suggest getting rid of fractions. How do you get rid of the 1/2 and the -2/3? Let's multiply everything by a common multiple of 2 and 3. The least common multiple is 6. So why don't we multiply everything on both sides of the equation by 6, or 6/1, okay? So let's distribute the 6 over everything on the left-hand side. So 6 times 1/2 is 3, so we're left with 3x. 6 times -2/3, well, let's see, that would be 6 times 2 is 12, and 12 divided by 3 is 4. So that would be -4y. And then on the right-hand side, 6 times 8 is 40. Okay, we get something that's more manageable. Now, we still need to isolate y. So let's subtract 3x from both sides. So we're left with -4y equals 48 minus 3x. Now, let's divide everything by -4. So once we divide everything by -4, we get y equals, let's see, 4 goes into 48, I believe, 12 times. So that would be -12. And then -3 over -4, those two negatives cancel out to be positives. Oops, to positives here. So that would be plus 3/4 x. Okay, now let me move it up here so we have a little bit more room. So we have y equals -12 plus 3/4 x. We're very close to y equals mx plus b form. Now do you see that we can just switch these two? So we get the 3/4 x first. So it's y equals 3/4 x minus 12. Now this is an equation that we can graph. Our slope is 3/4 and our y-intercept is negative 12. Let's try one more. All right, here we have another equation that is not in y equals mx plus b form. This is actually the last equation in this video. I would actually like you to do this problem, try to get this into y equals mx plus b form. You can work it out on your own piece of paper, and then once you're done, I'd like you to restart this video, and then I'll do the problem, and you can see if you got what I got. So why don't you pause the video now. Okay, so hopefully you just did the problem. The first thing that we're going to do is get rid of our denominators. So we have 3's in the denominator, so I would suggest multiplying everything by 3/1. So that will then get rid of our denominators. So let's distribute here. So this is going to be 3 times 2/3. 3 times 2 is 6. 6 divided by 3 is 2. So it's basically just canceling this out. So you're left with 2x on the left-hand side. Now let's distribute this 3 over everything in here. Now negative 4 times 3 is negative 12. Negative 12 divided by 3 is negative 4. So it's basically just like crossing out these 3's. So you're left with negative 4y. And now finally we're distributing this 3 to this negative 8, and that will be negative 24. So now I have at least an equation that doesn't have any denominators in it. We need to isolate y now. So what I'll do is I'll add 24 to both sides here. All right. So we've got 2x plus 24 equals negative 4y. Now let's divide everything by negative 4 to get y isolated here. And I'm going to continue up here just so we have more room. So 2 divided by negative 4 is negative 1 half x. And 24 divided by negative 4 is negative 6. And then on the right-hand side, our negative 4's cancel out, so we're just left with a y. Okay, now we just need to flip this around. So this is a good equation. So if negative 1/2 x minus 6 equals y, then that stands to reason that y equals 1/2 x minus 6. So that's what I got. This is a fantastic equation that you can now graph with a slope of negative 1/2, and it goes through the y-intercept of negative 6. All right, thank you.